So, good evening, everybody. Thank you for coming to this very special lecture, Mr. Ken Krechmer. I know that fundamentally, what we're always thinking about is technology, cybersecurity, and policy. But here's the thing. Overlaying much of what you will do as scientists, engineers, technicians, professionals will involve standards. Standards. Interoperability. And as you know, initially someone gets into the marketplace and they want to exclude everybody else because they want to make $15 gazillion billion. Well, guess what? Over time, other folks develop software, hardware, etc. And in order for interoperability, there has to be, everybody say the word, standards. And today we're going to hear from a person who has thought deeply about standards ever since maybe 30 years before you were born. So please welcome Mr. Ken Krechmer, who is transformative. So please.
Thank you. Thank you. Okay.
All the devices.
Yeah, got it. Well, I think we're there. All right. Thank you very much. It's great to see so many people at 5 o'clock in the evening. So Isology is a multidisciplinary field. We're going to talk business, law, economics, electronics, computer science, mathematics, even physics. It's amazing how many fields Isology impacts. And in fact, I would suggest that Isology is the basis for all fields. That without some kind of references, nothing exists. At the Big Bang, what emerges is a Planck constant, the speed of light. Those are references that describe what we call physical reality. And it's from those references that all the other references emerge. Over time, evolution, all kinds of processes. And so Isology is the beginning of it all. I'll take questions and comments throughout. And if you start to get long-winded in the question, please recognize we've only got about 15 minutes and other people would like to hear the whole thing. So they have to be concise, and I'll try to respond concisely. Obviously, afterwards, I would be delighted to take as long as you like with any comments you might have. So thinking about this from a business perspective, you want to build a business, you need a market, you need to define some market, and you need to define some product and how they overlap. It's a profitable business. And I'm using the Venn diagrams here because they're a very good way of thinking about how things interwork. A simple example of a classic business model was a gentleman by the name of John Deere in the United States developed the shape of a plow that was very good for the soil in the Midwest. And other blacksmiths, that's what he was really, developed different plows because they were in different parts of the country. But it turns out that John Deere's plow shape was best for the largest portion of the country. And he was also a good businessman, and he created a very successful enterprise. But his plow, that shape, was his technology that created his business. And so the next, that's the industrial age, where we make things that are similar, and we keep making them, and we make a profit on them, and people like them, and they buy more. There's a product, and there's a market. The next age, the information age, we have communications business model, where all of a sudden we have markets, we have products, and that we have to have interfaces in order to communicate. And if you control those interfaces, you can be wildly successful. AT&T controlling telephone systems, Intel controlling the interface to the standard processor, Windows controlling APIs to the Windows operating system, et cetera, et cetera, et cetera. Nokia controlling the patents on a large number of 3G cell phones, so forth and so on. In each case, by controlling those interfaces, there was enormous economic business opportunities. So the communications business model brings in this whole new thing. And then, of course, who standardizes the interfaces? As Jim was saying, do the interfaces come by who controls them, or does the market demand some sort of broader standard? And what the heck is a standard anyway? Is it created by some committee that I've never heard of? Is it created by anybody who represents my interests? Is it created by a government? Et cetera, et cetera. All kinds of different standardization committees. So let's talk for a second about standardization. First, there's an idea. Whenever we're talking about standardization, somebody says, let's do this new thing. And we think about it, and we think and say, oh, there could be a product for that. There could be a market for that, a need for that. So at the top of this clock face, 12 o'clock is the idea, the beginning. And so the clock moves clockwise to the right. And the first kind of standards we can create is there is nothing that exists, and we're going to create anticipatory standards. Standards before the product exists. The ITU is famous for that. Why? Because they started out from the telegraph side. And you had to create a standard for the wires before anything happened. We had to agree on which kind of wire we're going to use. We're going to be 2 or 3, 1 with ground, all those kind of things, before anything can happen. So there is no product, no communications without anticipatory standards. And so the idea comes first. Let's send signals over wire. The anticipatory standards come second. Then the product, a telegraph key, a ringer, comes third. Jumping over the left-hand side, so at 6 o'clock, the product or service emerges. It exists. We got it. But jumping over to talk about responsive first, many times this was the case with IBM. This was the case with Windows APIs. The product comes, and then afterwards is created a standard. Why? Because we want the market gets big, people like the product, they use it, like Windows Word, and then there is an enormous political fight about why should we standardize my competitor's product. So responsive standardization is very, very political. Anticipatory standardization is very, very technical. What's the best standard? Why is it best? I want it best this way. You want it best that way. We'll fight about it, kind of stuff. But responsive standardization is almost totally political. Some guy got out there in front of the others and started a market, and I don't want to standardize his product. That's too much of an advantage. And then the fights become, so if you were heard about the enormous struggles with the ISO standard for Word API, it was ridiculous. Countries got involved, and governments, and just a mess. So interestingly enough, early on in the 80s, 90s, a new concept emerged from a new organization called the IETF, the Internet Engineering Task Force, the people who are responsible for the Internet standards, which are called RFCs. And they are fundamentally participatory because they talk about at least 2 instantiations and running code. So you have to have something that works first before you create the standard. And yet you can't create the standard until you have something running. So it's kind of this, let's do it together stuff. I'll agree it's a standard if you can make it run. If you can make it run, I'll agree it's a standard. If you'll standardize it, I'll make it run, backwards and forwards. So we have participatory standardization. The fact that IETF pioneered participatory standardization really was why they hit the ground running so well. There was the ITU, which had done telephone standards for 100 years, telephone and telegraph standards. And ISO had been doing standards successfully since after World War II. And there are all kinds of gazillion, IEEE and all kinds of other organizations doing all kinds of standards. And this flaky group, a bunch of techie academic guys came along and created standards, and that just took off. Well, one, this network was amazing, so the internet was amazing. Certainly that was the case. But from a standardization standpoint, they had a new way to run the game. And interestingly enough, they didn't even know it. They didn't know this stuff. This is the reason why it got successful. My job, I think, in terms of lecturing, is to help you with why things happen, so you have some tools to understand how they happen in the future. So, some definitions. An interface in a communications environment is a basis for comparison. Basically, my plug and my socket, they're related to each other. If they don't relate, if they don't fit, there's nothing there. There's no reference. It doesn't work. So a standard is a codified, quantified reference imposed by an authority. If you come from an economics background, Friedrich Hayek, Rules and Order, basically discusses how rules and order are imposed by authority, which we could call the authority of government, we could call it a committee, we could call it a set of governments like the ITU, or the market. Lawyers tend to use a weird term called de facto and de jure to describe standards, which helps to confuse them. And that doesn't really do us much good. Because with a good example would be the ISO standard for the Word API. The Word API was a de facto standard but after it became an ISO standard, it was a de jure standard. So, which is it? First it was one, and then it was the other. So, de jure and de facto are terms that are time relevant. And when people use them and don't give you when are you talking about, they're just confusing things. So, avoid them. Standardization is an interesting thing. We might think of standardization as the process of creating, implementing, or using a standard. You might go to a committee, and on this committee you develop an RFC. You are creating that RFC standard. You might be a user, and you might say to your boss or your peers, I think we need to standardize on Word for all of our documents, or PDF, or something like that. And you're implementing that standard. You didn't create it, but you're certainly in that organization or that group defining what it is. So that implementation is very important. Or you're a user, and you say, I use the Word operating system, or I use PDF files, or I use PowerPoint, or whatever it might be. I'm a user of this standard. And here, of course, by using Word standard, before it was an ISO standard, it's a de facto standard. And after, it's an ISO standard. And as a user, and users, implementers particularly, really don't even know where it comes from. They just use it. Everybody else uses it, I use it. Standards are much like air. They're all around us. They're absolutely necessary, and we don't know they exist. And they're absolutely everywhere. Here's a complex chart of order and rules. So on the left, it's established by, and how order occurs, and the terms we might give it. So physical laws, we would consider them inherent, and their nature. That's what nature does. Then we have conventions. We don't see any plan to them, and we call them references. If I say to somebody, in order to get to my house, turn left at the big oak tree. The big oak tree is my convention for telling people where to turn left. Or maybe it's a street sign. I just have this convention that I use when I tell people how to get to my house. So those are really earlier than any sort of formal standardization. But they give us an idea of how fundamental this stuff is. It's everywhere. So with standardization now, something formal, a private entity can create a commercial interest which properly would be called the specification. A government can create some requirement. The FCC says, Part 68, your plug and jack must look like this, exactly, and have these electrical characteristics. We would call that de jure, and it would be a regulation. A formal standards body, and by formal I mean it has some agreed, IEEE or something. It may or may not be related to a government, etc. And we would call them consensus generally. There are consortia where consensus gets trickier. And we would call that de jure, and the term would be, from the legal perspective, a de jure standard. And then we can talk about consortium. And nowadays, there's so many different kinds of standards organizations that the word consortium is very treacherous. Is the W3C a consortium? Doesn't really seem to be. It seems like a formal standards body, but they're not really. And the biggest issue is consensus. Do they abide by some sort of consensus process, or is there a winner? Like this is a Microsoft-run standards body, and the people in the standards body are all organizations that are somehow beholding to Microsoft. And so what it decides to do is basically what Microsoft says it's going to do. And so there isn't really consensus in that case. And then, so that could be a standard. And then the market could establish a standard. We all agree that Word or PDF files from Adobe or something like that works really well, and we continue with it. And we call that a de facto standard. So what's interesting here, I certainly don't expect anybody to try to remember all this stuff, is how important this is. All of these words we use to describe this stuff are indicative to me of how important it is. That each little subtlety has a new word, a regulation, a de jure, a de facto. Lawyers think of it this way. Economists think of it that way. Very important, we add a lot of words. Standards are recognized as extraordinarily important, but we oftentimes just kind of let it go by. We just miss them. So as I was explaining before, we're going to talk about similarity and then compatibility. And those are related terms, but they're not the same. So plug 1 and plug 2 are similar. Socket 1 and socket 2 are similar. There is clearly no similarity between plug 1 and socket 1. That relationship we call compatibility. Very big point. To put this now into communications terms, here's a communication system. There's two transceivers, which consist of transmitter and receiver. There is an interface between them, if you like, the API, although it's protocols, of the transmitter and receiver. And within that interface, we can define protocols that go across the physical interface. We can define, I think everybody here is familiar with OSI. That's a comfortable term, 7-layer OSI model. So we can actually define 7 different layers of standardization under that model, and maybe more. We could talk about security as really a separate layer. So now I want to introduce some theory to make this more sensible. It turns out that standards themselves are layered. So the first thing we have, starting from the top, are symbols. We first emerge, the first kind of standard we need is we have to agree on a symbol. If we say that this is a bottle, then we are saying that bottles have a certain shape, they carry a liquid, they have a narrow top for pouring. We have all kinds of issues that we think of as the symbol for bottle. So the very first technical symbols are a number system. The amazing thing about standardization to me is that worldwide, the common number system is the Arabic system in every civilized country in the world. Even ones that had no relationship whatsoever to the Arabic number system. They still use the Arabic number system. Wow, standardization is really amazingly important when it crosses even all those boundaries. The purpose of a symbol is to identify, and its effect basically is to barter. Once I have a symbol, I can communicate, I can relate. I have 2 of these, you have 3 of those. What do we do? How do we relate? With measurement, which is now a way to start to quantify symbols. When I measure things and I can say the thing I have is bigger than the thing you have or smaller, and we can start to, again, be more precise about our trading. So units of measure, currency is another measurement system. The currency itself is a symbol. 1 penny, $1, 1 euro, those are symbols. And you write them as symbols. So I'm really got good grounds to say so. But the measure, they're units of measurement. They're units of measurement value. So once again, I have symbols, I have measurement as my next layer of standardization, of standards. And what they do is they make trading much more easy. I no longer have to say, I'll take 2 of those if you give me 3 of these. We can put this intermediate currency involved, and 2 of these is worth this much, and 3 of those is worth that much, and I'd like to change, please. So that's the next layer, succession of standardization. Much like the OSI model offers us layers of communications, what we're seeing is the layering concept is fundamental to complex structures. Evolution, the whole genus phylon system of describing living forms is a layered structure. Wherever we see complex systems, we see layered structures, and standards are the same. So after measurement, the next one we have is similarity, where we have now the ability to define a set of things as similar. We could use a Venn diagram for that, a circle. Everything that fits in the circle that has the same elements of the next circle, that's similar. So if this set has the same elements as this set, they're similar. Where those 2 sets overlap, the intersection of those 2, in the Venn diagram sense of the 2 circles of similarity, the transmitter and the receiver, where they overlap, that's compatibility. That's how we talk. That's how we can mathematically, as set theory, think of compatibility as a relationship where 2 sets overlap. That's their compatibility. So, interestingly enough, going back to similarity, similarity emerges as a big deal in the late 1300s in Western cultures. In Venice, Italy, there's a place called the Arsenale, where they built galleys, warships basically, to control trade in the Mediterranean. And trade was economically hugely valuable because we had previously measurement, so we could do trade. And now, if we could control similarity, the people who funded, built the Arsenale were the Medici, famous for their incredible wealth. Their wealth came because they controlled Venetian galleys, which were built on an assembly line. In the early 1400s, galleys were popping out of the Arsenale 1 per week. To put this in some perspective, there was a French, on the French coast, which is not that far away, the Mediterranean, there was a place where they were building galleys. They built 1 per year. 1 per year. The French were not a poor people. They had an equivalent economic structure to the Italians at that point. So what happened? How did that work that you could build 1 per week here and create incredible wealth, and you were building 1 per year over here? Standards. Standards for similarity. Not the Medicis, but the organization that was running the Arsenale actually created the very first patents in the Western world. I don't really know about the Eastern worlds well enough. There you would get, if you were clever and you created a better oar or shape of a boat rib or oarlock or whatever it might be, and people thought it was better, they would give you a piece of paper that says, when we make this, we will pay you this much money. And that became the beginnings of a patent system, actually, as that evolved. And that was patents about similarity. Very, very powerful. And now we have things like ISO 9000 for manufacturing process. Totally ethereal, imaginary kind of process definition. Those are also similarity standards. We have exit signs for safety. Those are also similarity standards. We have seat belts in cars for safety, also similarity standards. So we have all kinds of places where we decide to standardize things. Our purpose is replication, which is manufacturing, and the desire is to increase efficiency, economies of scale. And that's what happened. If you built the galleys one at a time, it took you a year. If you built them on an assembly line where every rib was made, and you can literally go to the Arsenale to this day and you can find on the floor the shapes carved in the wood, in the wooden floor, which were the shape of the ribs that you were supposed to match. The standard was in the floor. It was right there, and they were carving the wood to match it. It's gorgeous. So that was the industrial age. And this idea of economies of scale was hugely valuable. And in the 1920s now, Ford Motor Company invents the assembly line. Well, not really. It was invented a long time before. And there are many iterations. In the 1700s, they were building sailing ships, and the eye, where you take ropes and pass it through holes in the wood, that piece of wood was called an eye, and that was being built on an assembly line because a sailing ship took hundreds of them as the kind of a cheap pulley, basically. So there are many different examples of people basically just figuring it out, making it better, figuring out how to standardize things. But they didn't even know to call it that. So with compatibility, we've got railway gauge in the 1700s. And here we start to get some interesting things. The French railway system has a different gauge than the German railway system on purpose, because they didn't want their armies to be able to travel into their land. So they made them different. The Spanish had a different one than the French. Again, make them different. And during the Civil War in the U.S., the North had a different gauge than the South. The winner then picked the gauge, and the South had to move to the new gauge, which was the gauge for the North. Not surprisingly, this is how standardization works. Winner gets to pick. Could be market winner, could be war winner. Group 3 facsimile was an amazingly successful communications technology. And I was involved with not the beginning of standardization, but some of the later standardization of that. That'll, you know, for 40, 50-year span of time, all kinds of different facsimile machines were created, different speeds and color and black and white and Pell densities and page sizes, and on, and paper types, and they were all interworked and compatible. Fascinating capability. Gillette is famous for the razor and the blade. This is a very common story in business school, that Gillette controlled the market by giving away the razors and charging for the blades. You've seen a razor blade. It has a very funny shape to it. Have you ever wondered, how did it get that shape? Like, with all these lines and cutouts, and quite weird. The story is great. So Gillette gets this idea of making the razors and giving them away and paying and charging for the blades. And so guess what? He's got a market. Competitors come along and say, damn, I could undercut his blade price. That's really pretty expensive. And I figured out, you know, a good engineer, when somebody does something for the first time, that's hard. A good engineer can do it the second time really pretty fast. So yeah, Gillette really pioneered some great new metallurgy techniques, some great sharpening techniques. Those were powerful tools, but good engineers could copy them really fast. And so pretty soon, Gillette discovered that people were selling their blades for his razors. So his next step was he patented, or tried to, and we have the applications, they exist, his razor shape. And the patent office said, no, you can't patent the shape. That's not new technology. So then again, he's struggling with making his market and controlling his market. So then he starts to add complications to the shape. Until he gets to a shape that's complicated enough, the patent office said, yeah, you can patent that shape. And that's the shape we've got. And it took several iterations. We actually have the documents, the various submittals. Hugely important understanding of the commercial world here. The people, he had a technology, sharpening new kinds of metal, very powerful, but not enough. He had a great idea for marketing. I'm going to give away the razor and sell the blade. Great idea, but not enough. There had to be a means to control. And he didn't know that. He kind of stumbled forward and came to it. And we can see that. And in business schools, they don't understand that what he was doing was controlling the standard. If I give away the razor and sell the blade, the interface between the two is my specification, I own it. How do I control it? And we see today enormous examples of companies who give away the interface and later on regret it. I see Google creating APIs, Facebook creating APIs all the time, which they don't know how to control. Basically, I'm going to work at CU today and tomorrow. I've got 2 lectures tomorrow. The first lecture tomorrow is in David Reed's class, and I'm talking more about policy issues relative to standards. The second lecture is in Dan Massey's class, and then I'm going to talk more about how you control these interfaces in ways that work in the current world. So today is, let's give you some background, let's get you excited, and then tomorrow is, let's take policy issues, which will be open standards. What does that mean? And then how to use this to create new markets and control them. So basically, the quick answer is to use adaptability mechanisms. And that's what we're going to talk about more and more, and I'm going to try to explain them. But for now, let me say that modem handshakes do that. It's called V.8. The success of Group 3 facsimile was based on a standard called T.30, which is an etiquette that basically goes back and forth between the 2 ends and says, what set of features you have, what set of features you have, let's pick a common set. SIP is a RFC, I forget the number, session initiation protocol, and it is basically an etiquette as well, although it has problems because it hasn't been tested like it should be. If you, again, not understanding the theory, the practice tends to get messy. So, sorry, my slide slipped a bit. That is a problem with the Adobe system, the PowerPoint system. Sorry, yeah, that's not PDF. This is right, PowerPoint. So we can think about our standardization and how relevant it is, because in the hunter-gatherer society, basically before 3000 BC, that's the society where symbols start to emerge. Some sort of written or even verbal communications emerges. We know with Homer's work, we start to see a full set of symbols emerge where we have vowels and consonants. The economic reinforcing mechanism is communications. This is a way for me and you to somehow agree. And we can do this by, on our fingers. We can count sheep by moving stones from one pile to the next, and say whether all the sheep that we piled over here are now back over here. And the authorities' involvement in establishing references, they dominate. The cubit is the pharaoh's forearm. From here to there, that's a cubit. It's not your forearm, it's not my forearm, it's the pharaoh's forearm. King Henry VIII, his foot is the foot, not anybody else's foot. The authorities dominate standardization. Why? Because it's huge. It's how you make money. Basically, if you control those things, you can tax trade. How many feet of this, how many pounds of that means you can levy taxes. And we didn't have in early times taxation systems which were based on income. That concept emerges much later. But we had taxation systems that are based on trade. And trade is based on measurement, and symbols are required for measurement. So the new policy is trading. And where trading really takes off is in the Agrarian Society. Now, the Agrarian Society starts off, and what that means is you start growing food, agriculture. What's important, if you're a hunter-gatherer society, you eat what you get. You don't have to count anything. Counting emerges much later. But if you're an agrarian society, you've got to have an area. You've got to have a number of seeds, a number of plants to feed a number of people. You've got to decide on things like measurement of area. You've got to decide on things like counting of people. And all the counting of cattle and counting of all the other things that become important when you're no longer in the business of subsistence living. You actually become a civilization. A huge transition. That transition is basically created by measurement. That's the set of standards we start to evolve. And now those standards are so important that they're basically controlled by the priests or the kings in every society in the world. Every. Primitive, advanced, they're very controlled. Hugely important. And because the new policy that you can start to create with an agrarian society is taxation. I'll take some amount of your trade, your creation, your growing, whatever it is. You can start taxation. So, as we talked about with the industrial society, it's based on similarity. Now I use measurements and I use symbols to describe what's similar. And I have the enormous scaling effects that are possible by that, which create enormous amounts of value. And now the authorities' involvement starts to change, and we start to see things emerge. One thesis I have is that in the Western world, the Royal Society in England emerges in the 1600s, which is pretty much around the development of the steam engine, to start to define what a measurement is. And now measurements of pressure and atmosphere and water and all kinds of other complex astronomical measurements. There's even people trying to measure the circumference of the Earth and relate it to a meter, all those kind of things going on. That's 1700s. So these new technologies emerge to deal with measurements. And the Royal Society now starts looking at how different people do different kinds of measurements. They've got an excellent body of brilliant scientists. And they have another interesting thing. So if you think of them as the first standards committee, they have a charter from the King of England to be the Royal Society. And if they were more farsighted, they might have called them the Royal Standardization Organization, because they were starting to create standards. And that's the inflection point. That's where Western technology goes flying forward, and the Eastern technologies, which are at least as good, if not better, in India, in China for sure, don't get there. That standardization process takes off in the West. And why it did that, probably totally random. It just happened in the West. That this idea of the bright people get together and think about how we standardize stuff that's important, which turned out to be measurement. And the king gives them a charter to do that. So what they say has to be listened to. It's important. It becomes a agreed upon standard. And that concept apparently did not emerge in other equally advanced societies. And the Western societies rock it off. So standards are very fundamental. So now, probably by the 50s, after World War II, the idea of compatibility is starting to become really important. A punched card was a big deal, but not, if you think about it, because that was the world's greatest way to store data. It was because it was a standard. I could build punch card readers, you could create punch cards, and you could pass them anywhere. When I was a young engineering student and computers were a pain in the butt, I had to create a program on a stack of punch cards and walk it down to the place where they read those cards, and something happened. And I had to write all of my instructions down in copious detail to give it to this person who, on a keypad, punched that card. Each card. And I had to look at the card and make sure that it was the right program. There were no mistakes, all that process. But that punch card was a standard. That was what was being carried around. This machine could create it, this machine could input it into the computer. The same with a mag tape, any other kind of standard you'd like to think of. The same with an abacus. That was a standard too, how you calculate and why you learn to use it. And it had the same functionality, even though some were made very pretty and others were pretty plain. So these are all mechanisms of how standardization is so important. So in the information age, compatibility starts to be the big deal. Telephone systems around the world start to change people's lives. All of a sudden, doctors are available. Life and death can be changed by a communication system. And what a communication system is a series of standards. And we started to get companies originally, and then later on, very quickly, the ITU gets involved because they're too important. The telegraph standards are too important. We have to communicate between countries. The ITU had France and Germany as members, even when the two countries were at war with each other, because having the telegraph work was too important. So it's amazing how important this stuff was. And we don't see it. It's just there. So the new policy now is we start much more to evolve into commercial systems, whereas the Industrial Revolution, you very often had governments involved in creating standards. There was the Bundespost in Germany, and the U.S. had the National Standards and National Standards something, and National Standards Bureau, NSB, and now it's NIST. So but they were government. They tended to be government run, and nowadays they still exist as governments. They tend to be focused more on measurement standards, and compatibility standards are created by consortia or other independent organizations which have grown up to do them. And so with these commercial systems, given another example, pipe. Originally, systems for pipe, for gas or water, were unique. The threading and the sizes were separate from each company. And with commercial acquisitions, purchases, and so on, there became a need to standardize these things, and they emerged from that commercial side. Railway gauges were early compatibility standards, and as I talked about, some of them were were basically, we want to be incompatible. There's a quote, a gentleman by the name of Puffert, who wrote his PhD thesis in economics at Stanford, brilliant piece of work. It writes about all the different railway systems in the world and their history, and how they were created. And so if you were building a railway system to do a mine, narrow tunnels and so forth, the tracks were quite close together. If you were building a railway system to carry big loads across plains, the tracks were quite far apart. And there was always a local engineer who got together with whoever wanted to build the railway system to say, I think this is the best railway gauge for you to use because you don't have big trees, and so we have to have short ties. All these reasons. There are always technical reasons. You'll discover with standards, there's always technical reasons. They're usually just nonsense in any long-term sense, but they're always reasons. And so we created incompatible systems, which later on have to become compatible to serve the public good. Okay. So now we're in the internet age, and what we've got is computers that are amazingly powerful, and they talk to each other, sometimes over no physical interface whatsoever, or no physical interface we can discern. There are energy being passed through wireless signals. And they have associated with them enormous amounts of memory. So let me ask a rhetorical question. If I have a computer here that's totally programmable and has enormous amounts of memory, and I have one here with totally programmed enormous amounts of memory, it doesn't matter what goes back and forth. It doesn't matter at all. Well, all I have to do is agree on what goes back and forth. So I don't have to standardize the we talk this way only. I can say, which way do you want to talk? If I'm multi-mode and I speak English and Japanese, and I pick up the phone and somebody says mushi mushi, then I could speak Japanese. That hello is an etiquette. That's how I'm not telling you anything you didn't know. I'm just telling you, do you want to talk? That's an etiquette. When we meet, we go through this, hi, how are you? But we're really just discussing whether or not we want to talk. That's our etiquette. And so with the internet, and once we have computers like us that are capable of deciding which mode we want to operate in, we create etiquettes to decide how to do it. And we no longer have to say, in order to start up this protocol in order to communicate, we agree on our etiquette. And that etiquette has no data or control in it until we switch to the data or control mode and we actually start talking to each other. And so that's why I use the term etiquette. And with etiquettes, as you'll discover, if you're with me for the next couple lectures tomorrow, you have amazing opportunities to change the way standardization is done. Because we no longer have to standardize the data and control, or all we have to do is standardize how we decide it. So very powerful. So, to kind of wrap it up, insights offered by the successions of standards, adaptability standards. One of the things I could do, I guess I didn't really talk about it enough, we could actually agree to have non-standard mechanisms. In other words, I want IBM's form of data, not the public form of data, because I think that form of data is better. So if the etiquette basically sends the trademark IBM in one direction, the trademark IBM in the other direction, the two ends say, oh, okay, we'll agree to send the IBM form of data. Or General Motors form of data, or Adobe form of data, whoever. And from a standardization standpoint, I don't fight with anybody. You want to send your form of data? Yes, Mr. IBM, you have a code point. Here it is in the second field, this record. This is your code point. And if it goes this way and it goes that way, it's yours. And by the way, if somebody cheats and says, well, my customers will buy this IBM form of communications better than some other forms of communications, so I'm going to steal it. Just copy it. I'm an engineer. I'll put a data scope on it, look at the interface, decide how to make it the same. I'm going to copy it. So then the IBM lawyer comes along, puts a data scope on my stream, and says, look, he's using the trademark. He's using my client's trademark. There it is in the data scope. You don't have to go to some patent case, spend 10 years and millions of dollars. You go to a court and say, here's the reading from the data scope. This guy's stolen my trademark. Give him make an injunction. Tell him to stop. End. So when we have adaptability, we have all kinds of new ways to deal with problems which have been very, very painful. Remember, patents were created for similarity. In the Venice, they were created to define similar things. We now apply patents to compatible things. Well, hey, wait a minute, that's not fair. There's no invention here. This guy and me, we got together and we agreed to do this. That stops, you know, why should I have to pay for this? And many companies get really annoyed with that. Why do I have to pay in some way for that? So with adaptability, we can avoid it. You can pay for it if it actually offers advantages, capabilities that you didn't have before. The compression is better, the encryption is better, the speed of response is better, whatever it might be. Great. If it offers advantages, then you'll probably figure out a way to pay for it. But if it doesn't, you'll use the others. And you won't be a second-class citizen. The interface supports everything. So patents apply best to similarity. We need to limit patents that read on compatibility. We need to avoid patents that read on adaptability, which is pretty easy. The adaptability mechanism, the etiquette, should be very simple. Low speed. It just doesn't have to do a lot of stuff. There's no video real-time transfer necessary here. You can transfer millions of bits over these interfaces, and that's just not very much. And that will be a lot of code points. So that's my story for today. Thank you very much.
So I have a question.
Yes, sir.
I'm sitting in the back of the room, and I'm asking myself, did Ford know about what had happened in Europe, and did that then become part of the assembly line? Was he aware?
I don't know. There are any number of fascinating history questions. If any of you happen to be history majors, thinking about standards in history just fascinates the heck out of me. I don't know that. I give you another one. The name for the company which became dominant in the largest industry in the U.S. at the beginning of the 20th century was Standard Oil. It was founded by Rockefeller and an engineer. The engineer, not long after not early stages, but reasonably early on, left the company, an extraordinarily wealthy man, and was quite happy. But I suspect that he was the one who was standardizing the couplings for the pipes and the oil fields which they were using. But I have most of these records I've chased around are in upstate New York, and I'm again a history major who would like to write their PhD thesis. That would be a great one. Was Standard Oil a pioneer of oil field standards? And like I know they invented tanker cars, but you know, were there couplings to? Near as I could find, they just stuck a hose in the top of the hole and filled the car with oil. And same with, it was total gravity feed stuff coming out. So I don't think there were, but it deserves. Yeah, there's so many in the history side. When I go to a museum, I get all excited because you can actually start to see the different effects of similarity and compatibility in a civilization. And the damn curators of the museum don't discuss it at all. It's like, come on, guys. This is really important stuff. It's basic. You know, the Incas were tying these knots to describe basically a counting system. And so those knots represented a mechanism of a value mechanism, deciding value. And that's a standardization system I'd love to see more information on. And they don't know that. They don't really recognize that as that. But yeah, it's a fascinating field. Stick with me in the next couple lectures. It gets better.
So, again, let's thank our speaker.
Cool.
And then, of course, we have a token of our appreciation, also in swag bag. And we have an image of Boulder from one of the local artists. And on behalf of the program, ITP, soon to be
TCP.
so.
Boulder. Oh, fantastic.
So thank you very much,
Thank you.
and we appreciate it.
Thank you.